Architectural systems and building construction.
In this segment, we'll discuss fire resistance rated assemblies.
The project inspector familiarization with the DSA approved documents, building layout, and fire and life safety features is essential. Fire protection concepts include active and passive protection. Active protection is defined as those things such as fire alarm detection systems, fire sprinkler systems, and smoke control systems. Passive protection are elements such as fireproofing, through and membrane penetration fire stop systems, fire resistance rated construction, and egress systems. Please review inspection card sections 3, 4, 5, and 8. Also, inspection manual sections 3.3.4 for smoke control systems, 3.3.5 for fire-rated assemblies, 3.3.6 for fireproofing of structural members, and 3.3.7 for concealed spaces. Pay special attention to construction assemblies and make sure that the construction of such assemblies does not deviate from DSA-approved construction documents or manufacturer's listed details. Architectural systems and building construction elements can consist of the fire protection of the structural frame, construction of any fire resistance rated walls and horizontal assemblies. Firewalls, formerly known as area separation walls, are used to separate buildings into allowable areas or separate different types of construction. NFPA 221, an acceptable design alternative, permits a double firewall to be provided. All firewalls must meet the structural stability requirements of the building code. Fire barriers, another form of fire resistance rated wall, commonly known as occupancy separation walls, can be horizontal and vertical. Voids between fire barriers and non-fire resistance rated roof assemblies must be constructed appropriately. Refer to Section 706.2 of the California Building Code for structural stability criteria. This is the section that permits NFPA 221 designs to be deemed compliant with this criteria. 706.6 and 706.6.2 of the Building Code also note that firewalls in buildings with sloped roofs greater than 2 and 12 must extend beyond the roof surface to a height equal to the height of the roof located 4 feet from the firewall plus 30 inches. Verify compliance with the plan details. Section 707.5 pertains to continuity of the construction of fire barriers. Fire barriers must extend from the top of the foundation or the floor ceiling assembly below through to the underside of the floor or roof sheathing above, slab or deck, and shall be securely attached thereto. Such fire barriers must be continuous through all concealed spaces, such as the space above a suspended ceiling. Joints and voids at intersections must comply with sections 707.8 and 707.9. 707.9 of the Building Code states that the voids created at the intersection of a fire barrier and a non-fire resistance rated exterior wall assembly must be filled.
Fire resistance rated assemblies may consist of fire partitions, commonly used for corridor construction, fire barriers, commonly applied for labs, vocational shops, and cooking kitchens, smoke barriers, and horizontal floor ceiling and roof ceiling assemblies. It is important to note that where walls of science labs border a corridor of rated construction, the wall element that is part and parcel to the science lab must be maintained as a fire barrier, as it has a higher degree of construction. Project inspectors must verify the integrity of the wall continuity at the intersection of the fire barrier with the fire partition. Remember, integrity and continuity of fire resistance rated construction is essential to ensuring effective fire protection features.
Here's an example of a stepped building where the firewall extends 30 inches above the roof line of the lower roof, and then the wall is continued with 1 hour construction for 15 feet above the roof, and all openings within that 15-foot section must be protected with rated assemblies. Above the 15-foot elevation, no protection is required. Remember what a firewall is. A firewall is a fire resistance rated wall having protected openings, which restricts the spread of fire and extends continuously from the foundation to or through the roof, with sufficient structural stability under fire conditions to allow collapse of construction on either side without collapse of the firewall. Here are some other examples of the criteria. Note the 30-inch parapet above the roof surface. In the high-low roof condition or stepped building, the parapet height above the roof would be from the higher roof side. CBC Section 706 outlines various design methods to achieve compliance. These two conditions reflect the designs permitted per Section 706.6 and 706.6.1 for stepped buildings. This is another condition permitted by Section 706, specifically Section 706.6 Exception 2. Here you note that the firewall does not extend through the roof into a parapet, but instead terminates at the underside of the roof sheathing, deck or slab, a roof with a Class B roof covering, 1 hour protection for the structural steel supports. No openings are permitted within 4 feet each side of the firewall. And again, another example. This picture depicts designs from 706.6 Exception 3. Note that the firewall again does not terminate above the roof, but it terminates at the underside of a non-combustible roof deck or slab. Also has a Class B roof covering, as in the previous example, and again, no openings are permitted within 4 feet.
And yet another way to construct the firewall terminating at the underside of a deck or roof. Note that the Class B roof covering is provided. Still, no openings permitted within 4 feet each side of the wall, and there must be a fire retardant treated roof sheathing provided on the deck or roof, protected also by 5/8 Type X chipboard and supported on the edges of 2x ledgers.
Fire partitions. Fire partitions often used for the construction of rated egress corridor systems. In this detail, a 1 hour ceiling assembly is reflected. Note that this assembly has been prepared per Building Code Section 722.6.2 and consists of a prescriptive assembly. Here, a detail for a fire barrier. As with all tested assemblies, construction of fire partition and fire barriers must be per the tested assembly detail. Here's a parapet detail for a 1 hour What's wrong? Here you can see that the continuity has been breached. The drywall element is not continuous through to the top of the parapet. All elements of the wall must be maintained with proper continuity and construction. Here's another example. What's wrong with this? Note that the dense glass in this condition, the moisture resistant drywall, is not continuous to the underside of the deck. Also, you can see that the drywall assembly has created a void on the left-hand side, leaving an unprotected element. Here's another example. Remember, continuity, protection of openings. The flutes in this condition must be filled with the material as prescribed in the fire resistance rated assembly detail.
And yet another example of problem construction. What appears wrong here?
Important to verify the listing specifications for correct anchorage materials such as screws and nails, and that they are appropriate for the fire resistance rated assembly. This information may be found in the listed construction detail for the fire resistive assembly. Here's another example. The contractor in this case has added blocking. This blocking has created a cavity at the bottom of the wall, such that when the wall is erected in the upright position, the drywall protective membrane will not extend fully to the base. This creates an incomplete construction of the fire-rated wall. Here are some more examples. Note again that the wall board, the membrane, is not continuous to the slab. And another example that might be run into in the field. Here, a hole has been provided through the protective membrane to facilitate lifting the wall into place. This breach needs to be repaired to maintain the construction integrity of the wall. Fire-resistant rated elements are important, and it is important that they be constructed and protected appropriately. The project inspector must verify that the location of fire resistance rated walls, floors, and roof assemblies are as indicated on the plans. That the wall application type is correct. Firewalls where required, fire barriers where required, and fire partitions. The construction of the vertical enclosures, such as stair enclosures, fire barrier walls, and elevator shafts, their construction and the vertical opening protection. Hourly rating matches the DSA approved documents: 1 hour, 2 hour, 3 hour. Plans must show the locations of all rated walls, floors, and roofs. At a minimum, the floor plan for each discipline, architectural, mechanical, electrical, plumbing, fire sprinkler, fire alarm, etc., must show the locations and the hourly rating of fire resistance rated walls and floor ceiling assemblies. Plans should also include construction details and the references thereto for each type of tested assembly, including the specific details where assemblies of different types or hourly ratings may intersect. Signage and identification of fire resistance rated walls in the accessible spaces above the ceiling must be provided. Duct penetrations of these walls, fire dampers, smoke dampers, or combination fire smoke dampers have been provided. Proper fire strop penetration materials have been provided for the through and membrane penetrations. The location and termination of firewalls with respect to any structural, mechanical, electrical, or plumbing components must be per DSA approved documents. Ensure that fire dampers operate correctly and close upon introduction of smoke during testing. Sampling tubes must be verified as being installed in the correct orientation. Ensure dampers are reset after testing. It is not uncommon for fire dampers installed during construction to operate one time and then around the end of construction have become askew through other movement of buildings or systems, and they are not now operational. This must be verified.
And here we have a depiction of corridor construction, i.e. a fire partition, and vertical openings constructed using fire barriers, stair enclosures, and elevator hoistway enclosures. The inspector should note that Section 403.2.3, Structural Integrity of Interior Exit Stairways and Elevator Hoistway Enclosures, as represented in the Building Code, states, for high-rise buildings of risk categories 3 or 4, they need to be constructed in accordance with Section 1604.5. Further, in Section 403.2.3.1 for wall assemblies, the code states, the wall assemblies making up the enclosures for interior exit stairways and elevator hoistway enclosures shall meet or exceed the soft body impact classification level 2 as measured by the test method described in ASTM C1629. The project inspector will also be verifying that the door swing is correct. Doors serving occupant loads of 50 or more must swing in the direction of egress travel. Also, verifying the door hardware. Are electromagnetic hold-open devices used? If so, the operation of these devices must be verified that they release upon initiation of the fire alarm system. Also, the numbers of exits from the building and from the room. Also, signage, such as exit signage, stairway identification signs, fire sprinkler riser room, and electrical room signage.
Further, we want to verify that the fire protection of the structural frame has been provided. 1. That the protection method is approved, that the use of listed assemblies has been achieved, and that the proper application and construction has been per the details. All fire-rated wall assemblies, where occurring through concealed spaces, must be provided with signage indicating that the wall is of rated construction. Here's an example of one type of sign that may be used. It notes the hourly rating, the wall type, in that it is a fire smoke barrier, and that all openings must be protected. Pre-manufactured signs are not necessarily required, but the information must be provided on the wall in a permanent nature. No marking with a pen or stapled paper signs.